Okay, today I'm going to work through a review for the final exam. Let's start on number 1. Solve the absolute value of negative 8x minus 3 equals negative 8. The absolute value is isolated on the left-hand side, and I notice on the right that it's equal to a negative number. The absolute value can never equal a negative number. So my answer is no solution. For number 2, solve 5x plus 1 in absolute value equals x minus 6 in absolute value. I have 2 equations I need to solve. The first one is 5x plus 1 equals x minus 6, or I know that 5x plus 1 can equal negative x minus 6. The one on the left, I need to subtract 1 from both sides, and I get 5x equals x minus 7. Now subtract x from both sides. I get 4x equals negative 7. Divide both sides by 4. And I have x equals negative 7/4. That's one solution. Solving the other equation, I'm going to distribute the negative out front on the right-hand side first. 5x plus 1 equals negative x plus 6. Now I want to subtract 1 from both sides. I get 5x equals negative x plus 5. Add x to both sides, and I get 6x equals 5. Dividing both sides by 6, and I get x equals 5/6. Number 3, solve the absolute value of quantity 2 minus 3x greater than or equal to 11. I notice that I have a greater than or equal to inequality. So to solve this absolute value, the absolute value is isolated here on the left. I'm going to remove the absolute value sign and say 2 minus 3x greater than or equal to 11, or 2 minus 3x is less than or equal to negative 11. Let's solve this one first. I need to isolate x by itself on the left. So I need to subtract 2 from both sides. And I get negative 3x greater than or equal to 9. Divide both sides by negative 3. And I need to remember that when I multiply or divide by a negative, I need to flip the inequality symbol. So I get x less than or equal to negative 3. Now let's solve this inequality. Subtracting 2 from both sides leaves me with negative 3x less than or equal to negative 13. Dividing by negative 3 on both sides. Again, I divided by a negative, so I need to flip the inequality. I get x greater than or equal to positive 13/3. The two numbers on my number line are going to be negative 3 and then 13/3. Over here, I want all values that are less than or equal to negative 3. I need to color in negative 3 because I want to include it. There's an equal to. And all numbers less than, so everything to the left. Now for this inequality, x greater than or equal to 13/3, I want to color in 13/3 because it's an equal to, and then everything bigger than 13/3. So the solution to this inequality in interval notation, will be parenthesis negative infinity, comma, negative 3 with a bracket, union, bracket 13/3, comma, infinity with a parenthesis. Number 4, solve the inequality absolute value of 5x minus 4 minus 9 less than negative 1. This absolute value is not isolated here on the left. To isolate it, we need to add 9 to both sides first. When we do that, we get the absolute value of 5x minus 4 is less than 8. Now this absolute value is isolated. Since we have a less than absolute value inequality, to solve that, we get rid of the absolute value sign. So we have 5x minus 4 is less than 8. And we know that negative 8 has to be less than 5x minus 4. I like solving it as a compound inequality, written as 1. Our goal now is to get x by itself here in the middle. To do that, add 4 to all three sides. I get negative 4 less than 5x less than 12. Now I want to divide all three sides by 5. So I get negative 4/5 is less than x is less than 12/5. So the two numbers on my number line will be negative 4/5 and 12/5. Since I do not have equal to's, those numbers are going to be open circles. And I want all values in between those two numbers. So my shaded region is here. In interval notation, my answer would be negative 4/5 with a parenthesis, comma 12/5 with a parenthesis. For numbers 5, 6, and 7, it's asking if the given relation is a function. And so for number 5, they give you a set of ordered pairs. And one thing I want to draw your attention to is these two x values repeat. In order to be a function, the x values cannot repeat. So does this represent a function? And the answer is no. It is not a function. For number 6, does this graph represent a function? And the answer is no, because it doesn't pass the vertical line test. If I draw this vertical line, it would intersect my graph in more than one point. So number 6 is not a function. Number 7 is a function, because no matter what vertical line I draw, it will only intersect my graph in one point. So number 7 passes the vertical line test. Number 8 and 9, they give you the graph and they ask you to find the domain and the range. Remember that the domain corresponds to x values and the range corresponds to y values. For my domain, on number 8, what x values does this graph correspond with? It starts here at x equals negative 3. All of these x values up until x equals 0 are on the graph. And so my answer would be from negative 3 to 0. Notice that I include those values because these are closed circles, and so it's going to have a bracket. Okay, for the range, I want to come in from the bottom of the graph. What y values do I start finding points on my graph? From negative 5 up to negative 1. Again, since these points are closed, they're going to correspond with brackets instead of parentheses. For number 9, I see that no matter what x value I pick, I can find a point on my graph. So the domain is going to be all real numbers. But the range is only this one particular y value, y equals 8. So I have braces and just the number 8. For number 10 and 11, do you see a function here? Y squared equals 5x. Does that represent a function? And the answer is no, because if I tried to solve for y explicitly, I would get y equals plus or minus the square root of 5x. There's two functions here. And so the answer to this is no, that is not a function. Number 11, y equals 5 divided by x minus 1. That does represent y as a function of x. Again, you can solve for y explicitly in terms of x on number 11, so it is a function.